All right, good afternoon, folks. So today we're going to be looking at sum and difference identities. So the way these work is you'll probably need your unit circle like this, okay? And then you'll also need this trig value chart that looks like this, okay? And then you have your formulas. You have the sum of angles and the difference of angles, where you have your sine is a plus b is equal to this, cosine a plus b, tangent a plus b is equal to this, and then sine minus, and so on and so forth. So essentially what we're going to do is we're going to evaluate angles, whether it's in degrees or radians, okay, and then show you how to use these formulas to actually do this. So now I'm not going to go through every single one of these so that you know, but I'm going to kind of go through the gist of everything, and then we'll go from that point on. Okay. So the first thing to know is this: anytime you do these, you want to make sure that you have an understanding of degree measurements in terms of knowing that, if you do 90 plus 120, it's equivalency or it's equivalent to 210, so on and so forth. So, and what I mean by that, I'm sorry, is the fact that, if I do 90 plus 120, it's the same as 210, which is down here. That also means that if I did 2 over 3 pi and pi over 2, that's going to be equivalency to 7 pi over 6. Kind of like that, okay? So that's what I mean by that. And then the second thing is that when we do these, we're going to kind of be doing these a little bit backwards. Beforehand, when we were doing some identities, we would basically figure out, if it was a sine of 1/2, it's equivalent to pi over 6 or 30 degrees. Now we're going to be working backwards where we're figuring out sine of 30 degrees, is equal to 1/2, or the cosine of 30 degrees is equal to root 3 over 2. Okay. So the first thing I want to figure out is a way to rewrite 105 using all the degree measurements that I actually know. Okay. And there's different ways of doing this. There's different ways of doing this in terms of degree measurements. You could do it as a sum or a difference. I like to try and keep it as simple as possible. And so like 105, for example, if I just look at my triangle first of all, my circle first of all, you know that 105 is not on here. But I can still find a sum of 105 by adding 60 and 45 degrees. So I can rewrite sine of 105 as a sine of 60 degrees plus 45 degrees. And that's important because what that tells me is that I can use the sine of a plus b to rewrite and solve and evaluate what I want to know. So in other words, I'm going to use the sine of a plus b to determine the value by doing sine of a cosine of b plus cosine of a sine of b. Okay, so here's basically how it works. I take my 2 degrees, and notice how I wrote this with a and with this with b, and I figure out, okay, so if this is a and this is b, and I rewrite this with those angle measurements, then this is going to basically become the sine of 60 degrees times the cosine of 45 degrees plus the cosine of 60 degrees times the sine of 45 degrees. And then I can use my chart. Now, if you're used to using a triangle to do this, a circle. I keep saying triangle, a circle to do this, that's fine. But I'm going to use my chart value, trig value here to do this. So, for example, the first one says sine of 60 degrees. So the sine of 60 degrees is the same as root 3 over 2. So I'm going to replace this value, root 3 over 2, times the cosine of 45 degrees. Well, cosine 45 degrees is root 2 over 2, plus cosine of 60. Cosine of 60 is 1/2 times sine of 45. Sine of 45 is root 2 over 2. And I've replaced my values with all the values that I need. Okay. So then I actually just do the math real fast. Well, root 3 times root 2 is root 6 over 2 times 2 is 4, plus 1 times root 2 is root 2 over 2 times 2, which is 4. And then root 2 plus root 6, I'm sorry, root 6 plus root 2, I said that backwards. I can't really do anything with those, so it becomes root 6 plus root 2 all over 4. Okay. And if I want the actual value, I would plug this in the calculator to do it. But that's pretty much the answer that I'm looking for. Let me just verify one thing to make sure that I don't want what I need y'all to do is with a simplified answer versus just a simplified answer. I'm sorry. Let me pause here for a second. I know what I'm trying to say. All right, I'm back. So that's the kind of answer we want, a simplified answer. We don't want a decimal answer. I just want to make sure what I was looking for. And that would be how you do that. Okay. So now I'm going to look at another one. Sorry, let me get the papers out of here. I'm kind of all over the place right now. So like, okay. So the next thing I'm going to show you is what happens if it's a radian measurement. So radian measurements work very similarly. But I'm going to show you something a little bit different to kind of help with radian measurements. Okay. So like, for example, let's look at number 3. I have the cosine of 19 pi over 12. Now, if you know how to do fractions and separate fractions, that's great. But I'm going to tell you a different way of doing this. Excuse me. Wow, that came out of nowhere. And that's to do this. That's to convert your radians into a degree by multiplying by 180 over pi. Okay. And what that's going to help me do, it's going to help me determine what values I need in order to do this. So I get a 285 degrees. Now the formula again is basically to multiply by 180 over pi to get into degrees. And the reason why that's important, because if I look at my degrees, I can kind of figure out what would give me 285 degrees, because 285 obviously is not on here. It falls between 270 and 300. But is there a way to get 285 by adding two other angles together, or in some cases subtracting? Now in this case, 285 is more than 270, so you're not going to want to subtract, you're actually going to want to add. And right off the bat, I'm looking at this, and I'm seeing that 150 and 135 give me 285. But that also means that 5 pi over 6 and 3 pi over 4 are the two things I can add together to get this 19 over 12. Okay? So in other words, I can rewrite this as, so first of all, this is 150 plus 135. So I can rewrite this as 5 pi over 6. Oops, let me do this again. Cosine of 5 pi over 6 plus 3 pi over 4. Okay. And then understand too that there's more than one way of doing this. So it may not be that I do 5 pi over 6, 3 over 4. It might be another way to get 285. But I'm going to look real fast to see if there's a different way of doing this. Yeah, there is. If I did 225 and 60 degrees, that would also give me 285. So again, that's just one way of doing it. But the reason why that's important is because it helps me determine this is A and this is B for whenever, if I do the cosine, which is going to become cosine of A, sine B. I'm sorry, this is cosine. Cosine A, cosine B minus sine A, sine B. Okay, notice it's a different formula. Okay, kind of like that. And again, if you're not sure where I got that from, here, cosine of A plus B is equal to cosine minus sine. Okay. So then once I do this, I go into my ideal and I say, okay, where's my chart at again? And I'm going to kind of just move down here so I can have a little bit more space to do this. But cosine A, so A is 5 pi over 6. And if I find 5 pi over 6 or 150 there, this is sine, this is cosine, so negative 3 root 3 over 2. Okay, so cosine of 5 pi over 6 times cosine of 3 pi over 4 minus sine of 5 pi over 6 cosine, I'm sorry, sine, I gotta get used to that again, sine of 3 pi over 4, okay, then I can replace my values. So cosine of 5 pi over 6 is negative root 3 over 2 times cosine of 3 pi over 4 is negative root 2 over 2 minus sine of 5 pi over 6 is 1/2 times sine of 3 pi over 4 is root 2 over 2. Okay, then I do a little bit of math. So this is going to become positive root 6 over 4 minus root 2 over 4. And again, since I'm looking for an exact answer, root 6 minus root 2 over 4 would be what I am looking for. Okay? So that's how you do that. And again, if you're looking for more, I mean, all of these are posted already. This negative one right here, I do want to kind of explain this one to you a little bit. So the fact that it's negative, make sure you get that when you do the subtraction, again, you're going to obviously reverse your numbers. So 5 pi over 12, equivalency would be that times 180 over pi, which I believe comes out to be negative 75 times 5 divided by 12, which is, yeah. So that becomes a negative 75 degrees, okay? And again, to do a negative 75 degrees, I can look at this and try and figure out a way of doing it. Basically, it looks like I would do 150 minus 225 with one possibility. Okay. And this would be a sign of minus, kind of like that. Which then becomes whatever my values are. So my formula would change to sine minus A minus B, so sine A cosine B minus cosine A cosine B. And then, of course, this would be your A, this would be your B. So that's kind of the way that looks. Now, tangent, oops, let me go back to tangent over here. Tangent, very similar, and I'll do one for tangent so you can kind of see it. Okay, this is number 5. Okay, so the tangent, and again, it's tan of 13 pi over 12. And again, I'm going to do the same thing I did a minute ago. If I do 180 over pi to convert it to a degree, to be able to do this a little bit easier. So 13 times 180 divided by 12 looks like 195 degrees. So in order to get 195, I think I can do, let's see, that's 55, 195, 150 plus 45. So 150 plus 45, okay. So 150 is 5 pi over 6, and 45 is pi over 4. So that would be the tangent of 5 pi over 6 plus 5 pi over 4. Tangent formula looks like this. Okay, so I'm going to write it out. Tangent of A, which would be 5 pi over 6, plus tangent of pi over 4, that's B, all over 1 minus tangent of 5 pi over 6 times the tangent of pi over 4. Okay, that's the formula. So now I'm going to go through my chart and figure out the values that I need to do this. Okay, So tangent 5 pi over 6, and we find 5 pi over 6 is negative root 3 over 3 plus tangent of pi over 4 is 1 all over 1 minus tangent of 5 pi over 6 again was negative root 3 over 3 times the tangent of 5 pi over 4, which is 1. Okay? And then I do a little bit of math, and if I do this, this becomes 1 minus root 3 over 3 all over 1 plus root 3 over 3. And then let me check to see if how far we want to take this. It looks like we are doing conjugate. Yeah, we are. Okay. I was making sure how we're going to do this. So we're doing a conversion on tangent. So ones are going to become, so this is going to become 3 over 3 minus root 3 over 3 over 3 over 3 plus root 3 over 3. Oh, let me move my drink before I knock it over an accident. Okay. And then we're going to do some math here. It looks like I'm going to multiply oh, I didn't want to do that. Well, yeah, it's what I wanted to do. Oh, I see what I should have done. So anyway, so that's going to become, and I'm running out of room here, which is kind of odd. 3 minus root 3 over 3 over 3 plus root 3 over 3, which becomes, and I'm running out of room, so I'm going to move it down here. 3 minus root 3 over 3 plus root 3. Okay. And then I'm going to multiply by anyway, yeah, so I'm going to multiply by the conjugate in order to be able to clear this out. And I apologize if that doesn't look, let me kind of rewrite this. Root 3, root 3. Anyway, so the bottom is going to essentially become, let's see, is that 9 minus 3? Yeah. That'll become 9 minus 3 on the bottom. And I'm going to skip to kind of the math part of this. And on top, it looks like it's going to become 9. Is that 9 plus 3? Yeah. 9 plus 3 minus 6 root 3, which becomes 12 minus 6 root 3 over 6. Which reduces to 2 minus root 3. Kind of like that. Okay. Anyway, that's tangent. Okay. Let me see what else we got on here. Okay. So the next couple of things is just basically condensing instead. I mean, you essentially just put it together based on the formula. So what I mean by that is if you're given, like, for example, cosine of 300, cosine of 15, minus sine 300, sine 15. First thing you want to do is figure out, sorry, you can't see that, what formula does it match up with. And in fact, it's cosine, cosine minus sine, sine. Basically tells me it's cosine, cosine minus sine, sine. So it's cosine of A plus B, kind of like that. So basically, this is going to reduce to cosine of 300 plus 15. So this is A, this is B. So it basically reduces to cosine of 315 degrees. That's it. That's all you're doing a condension on those. Okay. You could have same thing with something other than that. So like if we had cosine of 2x times cosine of 4x plus sine of 2x sine 4x. And again, I use the same formulas. In this case, it's cosine, cosine plus sine, sine. So cosine, cosine plus sine, sine is cosine of A minus B. So this is A and this is B. Okay. So it's the cosine of 2x minus 4x. So it becomes a cosine of a negative 2x. Kind of like that. Okay. That's all you're really doing on those, on condensions. It's just working backwards. Anyway. That's all I have for y'all. I mean, that's what it is. And again, you'll need this chart here and probably this here if you're not familiar with the other one to do sum and difference of cosines. And this essentially would be your next assessment piece that you'd be looking at next week. So, hopefully we'll figure it out. Anyway, see you later. Bye.